All right. Let's get started. Pass it out at the old school. If you don't need another copy, let me know. All right. This 2 chapters is all about vectors. And y'all know what a vector looks like. This is what it looks like. It's just kind of a line segment. Anyone? And a vector has 2 things, and this is what we're going to focus on today. Magnitude. Vector has magnitude and direction. Because this test is so easy on Friday, you might have some definitions. It'll be fill in the blank like this, so don't forget that a vector has magnitude and direction. So here is a visual representation. This is what it looks like, just a line segment between 2 points. And notation, the way I write them sometimes is if you see a line with like 2 letters underneath it, what this is saying is this is vector PQ. So if you see a line, you would say this is vector PQ. Alright. So in a vector there's 2 points, which we know has an X and a Y for both of them. The position vector is a vector that starts at the origin. Position vector is a vector that starts at the origin, which is 0, 0. Sometimes you'll be told to write a vector in component form. That's component form is x2 minus x1, comma y2 minus y1. It's just the difference between your x values, difference between your y values. That's vector form. Component form. So in this chapter, the first thing we'll focus on is finding the direction and magnitude. And I'll explain how we do that. The direction is literally just what it's talking about, the direction in which the vectors go in. So direction is like up, down. Y'all know what direction is. East, west, sometimes it'll be said like that. And then it also has magnitude. And that's just the length of the actual vector. Now think about what I just said. The length of a line segment, how do we find that? Think back to geometry. How do we find the length of like a line, the length between 2 points? Yes, distance formula. Does everybody remember that, or do I need to write that down? Alright, distance formula, and you'll have to use this to find the magnitude. That's why I'm writing it under it. Good. It's x2 minus x1 squared plus y2 minus y1 squared. That's distance formula, and that's how we find magnitude. So this is very important. You'll have to memorize this formula for your test. It won't be on your test. Alright, this first one says state whether each quantity described is a vector or scalar quantity. So like I said, a vector has to have magnitude and direction. Kelsey, read the first one for me.
About traveling at 15 miles per hour.
Okay, so do we have a direction for number 1? Nope, just traveling 15 miles an hour. So what this is a scalar. Scalar quantity when it does not have direction. Again, a vector has to have direction and magnitude. Cade, read number 2 for me.
A hiker walking 25 paces to west.
Alright, so do we have the magnitude? Do we know how long he walked? How long did he walk? 25. Do we know what direction? West, so this is a vector. Very easy. Alright, Antonio, read number 3.
A person's weight on a bathroom scale.
What do y'all think, scalar or vector?
Vector.
So we know a direction for this person's weight. Nope, it's scalar. You might have 2 of those on your test. Alright, 4 and 5. Write the following vectors in component form. This is component form, going back to this. Here's the formula. And then we're going to find the magnitude, that's right here, of each vector. Okay? So the important thing, the only hard part about this, is realizing what is your x2, x1, y2, x1, y1, x2, y2. Now in slope it doesn't matter, correct? But vectors, it starts at a point and it's going to another point. So where does it start at in this one? Good. It says from this point, so that's where we're starting. So this is our x1, y1, and to this point, so this is where we're ending. This is our x2, y2. That's the only hard part. Alright, component form. The formula is x2 minus x1, comma, y2 minus y1. So what is this vector, or what are these 2 points in vector form?
6.
What is our x2?
Wouldn't it be 9?
6 minus what? Which is going to be? Very good. And then when we subtract y2 minus y1, we get what? Very good. Not yet. You're thinking about magnitude. What we just did is put it in component form. Now we're going to find the magnitude. And the magnitude will be written like this, guys. It's 2 absolute values with a v in between it. So this is component form. Now we're going to find the magnitude, which we have to use the distance formula. And we already found x2 minus x1, correct? x2 minus x1 was what? 9. So we'll just plug in 9 squared. We already found y2 minus y1. That was what for this problem? So 3 squared would just be 3 squared. So the magnitude v equals square root of, what's 9 squared?
81.
Plus, good, which will give us what? Alright, the only thing we have to do here is see if we can simplify square root of 90. What do I mean by simplify? Find perfect what? Squares that go into it. What's perfect square that goes into 90? 10 and 9. Very good. So the magnitude would be, I'm going to rewrite this up here. We have square root of 9 times 10. So what did you say, Colby? Very good, because you can take the square root of that 9. So what did we just find again? Magnitude. What is this part that we found? What's this called? Yeah, component form of a vector.
Wait, that was favorite 10.
Yes. So on the test, if it says put it in component form, that's this part. Finding the magnitude, this part. Alright, I want you to try 5 on your own. Go ahead and put it in component form, then find the magnitude. Let me know if you need some help. what did we get for the component part? Not finished? Okay. Who is finished? Raise your hand. Okay, I'll give y'all another minute. You don't have to be so spicy.
I was close to finishing.
Alright, what's the component form?
6 negative 2.
Everybody agree?
Yes.
Alright, so the magnitude would be what under here?
36.
36 plus 4. Very good. One thing I noticed that some of y'all, negative 2 squared is what? Positive 4. Even if your calculator says negative, they are lying. If you didn't put in parentheses, it'll say negative 4. So it's always plus right here anytime you square something. So we get square root of 40, which breaks up into what? 4 and 10, so the magnitude is?
2 or 10.
Very good. Everybody good with component form and magnitude? Let's move on. Alright, this next one. Write the vector v in the form AI plus bj, given its magnitude and the angle it makes with the positive x-axis. So here's the formula we need for this, and you will have to memorize this for your test, so put a star by it. It's not going to be on the test. The vector is going to be absolute value of v, and what is this? Magnitude. Good. So the magnitude of the vector times cosine of whatever angle times I plus sine of the angle j. That's why we're going to keep having Tricky Tuesdays. You have to know what cosine of certain angles are. This is just stands for an angle. If you want to put theta there instead, or x, that's fine. Alright, so now we're going to use the formula. Do we have the magnitude for number 6? Yes, the magnitude is what? Nope. 5. Magnitude is 5. So I'm just plugging it in, this formula. Parentheses, cosine of the angle, which is what is our angle? 60 degrees, and I'm going to put I beside it, plus sine of 60 degrees, I. Alright, cosine of 60. You can use the hand trick, or if you know it by heart, you know it's going to be what?
1/2.
Good. 1/2 I.
Shouldn't it be J on the side?
Yes, thank you. And now sine of 60, you can use the hand trick, or if you know it by heart, it's plus square root of 3 over 2, j. And now all we have to do is multiply. So this vector is going to be what? Go ahead. 5 over 2i plus j. Very good. This is the vector. Questions about that part? Alright, let's do one more together. Alright, I'm setting up the formula. What goes first? 14 parentheses cosine what? What? Plus. Very good. Now, take a minute to go ahead and find cosine of 120 on your own. What is it? 1/2? Negative 1/2. Because 120 is in what quadrant?
Oh, 2.
Good. Second. So it's going to be negative. So we have 14 times negative 1/2 I. And what is sine of 120? Positive or negative?
Positive.
Very good. J. Then when we multiply, we'll get V equals, good, negative 7i. Y'all got this. Come on.
Wait.
Plus 7 root 3 j. Very good.
Oh, you do it too.
It's 14 over 2, which is what? 7. All right, go ahead and try 8 on your own. Let me know if you need some help.
That's it?
Alright, so this one I'll go ahead and set up. We know it was V equals 25 cosine of 330i plus sine of 330j. What did y'all get for cosine of 330?
1/2. No, 1/2 of square root 0 2.
Good. Is it positive or negative?
Positive.
Because it's in what quad?
4.
Good. Square root of 3 over 2. What about sine of 330?
You got negative 1/2.
Good, because it's in the fourth quadrant, so we know sine's negative. So it's negative 1/2 j. So final answer would be what?
That equals 25 square root 2 minus 12.
Yes, or we can just leave it as what? Very good. 25 over 2. Either way is fine. Any questions on these? Very good. So we just found the vector AI plus BJ given an angle and the magnitude. I don't know if y'all, I've never taught geometry. Did y'all draw vectors in geometry?
No.
Are they required to do that? No? Okay. So in geometry, Sometimes you're required to draw vectors. I guess our geometries don't teach it. So if you're having V, this is the vector. 2V is just doubling its length. So this is how it would look. You just draw one of them, and you draw another one. It's just doubling the length. Does that make sense? The direction doesn't change. All you're doing is pretty much drawing it twice. What do you think negative V is going to do?
Go down. And go up.
Yes. Instead of going down, it's going to look the same, except the arrow is going to be pointed which way? Yes. And we're going to draw these in a minute. So just remember 2V, that means it's doubling the length. That's all. If it's negative, it's just going the opposite direction. Alright, and then component-wise, say if we're given this vector, if I were to multiply it by 2, what do you think I'm going to do to these values? Double them. Good. So it'd be what here? Very good. And what if I were to do negative V with this vector? What do you think that would do? Yes, just change the sign. So our vector would be what? That's it.
Why did you get 2 out of
Talking about on this one? Negative V just means you're just changing all the signs in this vector. So this would change to negative, this change to positive. Alright, flip it over. So this is geometrically drawing it. This is component-wise. We're going to look at drawing 2 more of them. These, for some reason, were really confusing to some people. Let's see how they go. Alright, V plus W means I'm adding them together. That means I'm combining the vectors. The only thing you have to remember is whatever one comes first, that's when you draw first. So I'll draw V right here. If we're adding these, you connect this vector, the tail end, to the start of this one. Tail end to the start of this one. So this is how it would look. That's V plus W. Put them together. The tail end of the second one goes to the point of this one. Alright, remember when we did this vector, if we change it to negative, we change the direction? Okay, so I'm going to cover up this V right here. Negative W would change this direction in the other way. Correct? So let's draw V first. That's what comes first, this one. Alright, now this is going to change directions. So the tail is going to be up here now, right? So the tail here is going to start here and go down in the other direction. So this is V plus W, this is V minus W. Does that make sense? That's geometrically. Now component-wise, you know what to do. If I were to add V and W right here, what are my like terms? Good, so when we add them, we'll get what?
11i.
And then when we add the other like terms, we'll get
-2i.
2J. Very good. When I subtract them, what signs are changing? V or W?
W.
Good. So what this looks like is 7i plus 3J won't change our V, but our W will change to what here? And plus 5J. Good. So when I combine them, I'll get what?
Wait.
3i plus what? 8J. Very good. Go ahead and do 9 and 10 on your own. I just combined 7 minus 4i and got 3i. And then 3 plus 5 gives me 8. Because the negative changes both of these. Go ahead and do 9 and 10 on your own. There's the vectors. For this one, you're multiplying everything in here by 2, then adding it to everything in here times 3. Do we need to go over one before we do these? Okay. If I multiply everything in V by 2, that would give me what? 6i. Very good. And then if I multiply everything in W by 3, that will give me what? Keep going. Very good. And I'm adding these two. How do I know? Because there's an addition sign in between. So 6i plus negative 6i will be what? Good. 0i. And then what's negative 10j plus 9j?
Just J minus J.
Good. That's it. Go ahead and do number 10 on your own. No, you don't have to. Okay.
Yeah, and then it's using this one.
Okay. Because I was trying to do it with this one, and I couldn't figure it
Yeah,
out.
and it was that one. So when you go on to, like, if you have a document, so whatever you pick from here. If you have a
Can I pick one out of here?
Yeah.
I don't know. I have one. Okay. Let me try to.
You probably got one in yours, don't you?
I doubt it. I just put notes and stuff up. It's not gonna load. But anyways, I just go on this one and then.
Mm-hmm. So now you can just.
Oh, okay. So I could do that on here,
Mhm.
or
Yeah. Or once you get here, and then you have to do
and then I have to open it.
the overlay.
Okay. So if I press this.
Yeah. Yeah, now we should be.
Oh, cool.
Yeah. And then you can
Thanks.
save that.
Thank you.
But
I have to get the eraser, I guess.
usually when you pick up this, you don't have to go to eraser.
That's gonna help me with this. Yeah.
You just have to remember to go back and capture it. 'Cause,
Okay.
like, you can't move the document like that. You can't do that on overlay.
Okay. Thank you. All right. Anybody want to share with their final answer what they got for number 10?
39, 21, 0.
Very good. Do I need to go over it? Cool. All right. Next one. What are these little lines? What are we finding? Magnitude. Good. And with magnitude, we have to use what? Distance formula. Good. Alright, so the first thing we're going to do is add these vectors together, v plus w, okay? So v plus w in this case would give us what? Just adding these two together. Come on. What is it? I plus what? I minus 2j? Very good. Alright, I minus 2j. And that came from adding v plus w together. Alright, what's the number in front of I? Very good. So to find the magnitude, it'd be 1 squared plus, what's the number in front of j? Yes, so just 2 squared. So we'd have the square root of 1 plus, which is, very good. Questions about that? Alright, do you think that number 11 and number 12 will be the same result? Let's find out. How do I find just the magnitude of v? Be the square root of what? 3 squared plus, good, and let me show you where he's getting that from. In v, the number in front of I is 3, the number in front of j is 5. Tell me how to set up the next magnitude. Very good. Alright, so this one, 3 squared is 9 plus 25. This one would be 4 plus 9. What's 9 plus 25? 34. 4 plus 9. Can I add these two? Why can't I add these two? Good. They're the same root but not the same number underneath. Can I simplify either one of these? Any perfect squares that go into them? Very good. Just leave it like that. Alright, last thing is drawing vectors. And I know it looks like it's easy, but I'm telling you, sometimes people get confused on these. So I'm going to try this overlay thing where I can draw on it. But first, let's go ahead and label this. This is vector A, this is vector B, this is vector C. Alright, for this first one, number 13, when it says A plus B, which vector do I have to draw first? A. Good. Let me try this thing. So now I think I can draw on it. Alright, I have to draw, A exactly like it is here. What can help me out to draw it exactly the same? Same length, same slope, everything. Oh, thanks. I have to find the slope first. What's the slope of this line, or this vector? Down 3 over 3. So my slope is, something like that, 1. Or, negative 1. Let's go ahead and draw that here. And you can draw it anywhere on yours. I'm just going to draw mine here. So I go down 1, 2, 3 over 1, 2, 3. Draw it exactly the same. There's vector A. Now if I'm adding B to it, what's going to be connected to the tip of this, the end or the arrow? The end. Good. And what's the slope of this line? Sorry, thank you. Slope of this one's 1, 2, 3, 4 over 1, 2, 3. So from here I'm just going to go up what? 4, 1, 2, 3, 4 over what? Up 4 over 3. Go 1, 2, 3, 4. 1, 2, 3. And that is what that we just drew? A plus B. Make sure you label it. Alright, next one. A minus B. Alright, what do I draw first? A. Very good. So I'm going to go down 3 over 3. 2, 3. Let's draw my starting point. 1, 2, 3. 1, 2, 3. Alright, what's different about B this time? It's flipped. So the arrow is going to be on this side, right? So the tail point needs to connect to this one. And I'm still going down 4 over 3. So down 4, 1, 2, 3, 4, 1, 2, 3. And that was what? A minus B. You can draw these wherever. Next one, 2B. So what am I going to do to B? Double the what? The length. So I double the what? Slope. Good. So I'll go up 4 over 3 twice. So I'll start here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. That's one time. Now do it again. 1, 2, 3, 4. 1, 2, 3. I'm sorry that this is so crooked. So that's 2B. Negative C. What's going to change about it? Will the slope change? Just the what? The arrow. Good. So I'll draw the same thing except my arrow will be going this way. So the slope of C is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So up 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Again, nothing changes except it's going to be going downward. And I don't know if we'll have enough room to do 17 on this graph. So, what now? Oh, good idea. Good idea. Alright, 3B. That means I'm going to extend B 3 times, right? So I'm going to use this line. 1, 2, 3, 4, 1, 2, 3. So I'm going to go up 1, 2, 3, 4, 1, 2, 3. So that's 3B. And then negative A, that's just going to change this arrow going this way. 3, 1, 2, 3. So there's A going in the opposite direction. And then plus 2C would be twice this. I'm going to run off going that way. What now? Not a drawing one, no. Yes, it'll be on the test. Any questions about what we learned today? Did y'all think the chapter was easy except the drawing part? Yeah. Alright, we'll focus on that tomorrow. Remember Trivia Tuesdays tomorrow. Oh gosh. That is so cool. Thank you for showing